Welcome to my cereal dilution video. Special shout out to my friend who ate 6 yogurts for me literally just 20 minutes ago. Okay, so here we have our 6 solutions. So we're gonna start off with our stock of orange juice right over here. So all we're gonna do is gonna take 1 milliliter of it, and we're gonna put it into the first dilution cup, which has currently 9 milliliters of water. We're gonna put it in, mix it around. Got a bit of dilution. And so that'll be our first dilution, aka 1/10 or 10 to the negative 1. Okay. Now we're gonna repeat that process with another draw of 1 milliliter. And we're gonna put it into another cup with 9 milliliters of water. Okay. And that'll be our second dilution, which is 1 to 100 or 10 to the negative 2. Okay. Now, let's do that again. Taking 1 milliliter of that, putting it into 9 milliliters of water. That will be our third dilution, aka 1/100th or 10 to the negative 3. With that, let's take our 1 milliliter of the third dilution, put it in here, mix it around, okay, and that'll be our fourth dilution, which is going to be 1 to the 10,000 or 10 to the negative 4. Okay, so we're going to be taking this 1 milliliter again, putting it into the final dilution cup for the fifth dilution, which is going to be 1 to the 100,000th or 10 to the negative 5. So, let me do some calculations real quick. Okay. Sorry, Lou, I am, in fact, not an invertebrate. So, let's talk about calculations. Let's say we stopped at the fourth dilution, which is 1 to 10,000ths. And then we took a milliliter of that and we put it on the plate. And then we grew 75 colonies. So what we're going to do, we counted up that 75 colonies and we're going to multiply it by the total amount of dilution. So that would be 10 to the fourth. All right, and then we're going to divide that by the volume of the culture plated, which was 0.1 that was added to the plate. And that'll give us a total of 7,500,000 CFU 2 milliliter, or 7.5 to the, I forgot what that is, times 10 to the power 6. Okay, but let's also talk about why counting the amount of bacteria is important. There's a lot of ways to count bacteria, such as spectrophotometry or actually counting them through a microscope, which I am not doing. That is a lot of work. But there's also what we were doing, zero dilution. Reasons why you may want to count bacteria is because you're studying them or because of health, food health. So scientists can zero dilute, count the amount of colonies, and then multiply it up from the dilution, and that's how much bacteria there's basically. Kinda. Anyway.